Hey, this is Sam Curry, and welcome to Breaking into Cloud Wallets, findings from 3 years spent hacking crypto-powered web apps. This talk is about an hour, so the slide deck by itself is it's a little bare, because I think it requires a lot of context from the talk. So I'll probably release it with some extra details during a week or so, but thank you for watching. This talk is mostly for people, I think, with traditional bug bounty backgrounds or web application security backgrounds. The talk isn't really going to cover much smart contract hacking. It's mostly web app security, right? So to kind of introduce myself, name's Sam Curry. I did full-time bug bounty for around 5 years, and I kind of tapered down a little bit near the end of that. I worked as a security consultant on and off for a year or two for kind of traditional pen testing. But about a year ago, we started a security consultancy called Palisade, and the goal with Palisade was basically providing AppSec security for kind of these crypto companies that are new, and maybe they have a lot of crypto security, but they didn't have a lot of web security. We noticed that there were tons and tons of companies that really weren't investing into web security, but ran these big crypto programs that were hosted on a website. I'm super passionate about AppSec research. I really love any sort of AppSec hacking. So kind of just my general background. But to kind of just break right into the talk, my introduction to cryptocurrency was probably around 2014, 2015. And this was when I was in early high school, and we were playing RuneScape, gambling, doing a bunch of really dumb stuff on the internet, and you needed cryptocurrency to either collect money from selling your in-game items or to buy stuff, right? So I was doing normal stuff with Bitcoin or whatever, and playing lots of video games, right? So when I started doing this, I kind of realized that the whole process had a bit of pain points. If you read the philosophy of cryptocurrency back in 2014 or 15, it's probably still the same today. It was all about decentralization, and that Bitcoin came out of the housing crisis, and basically the idea is we're gonna remove ourselves from the financial system, but this was never really the case, right? You have what's advertised as the Bitcoin transaction process, where it's Nick goes about transacting with another user, where you can transact cryptocurrency, but the issue still becomes converting that money into USD or into whatever currency you use, right? So here's a photo on the right of me, and I think this is 2014, and I'm having to go through an exchange, to buy Bitcoin, right? And in order to do that, you have to authenticate to the website, you have to show them your ID, and you have to pay USD for Bitcoin where it gets deposited into your web app account, right? So the whole decentralized part kind of falls apart with KYC. I'm sure there's people who are very oh, I only use cryptocurrency, and I guess that's kind of the introduction of stablecoins maybe help with that. But at the end of the day, if you want to buy stuff, you're going to probably have to trade something, and what you trade over is probably going to be USD. And at the bottom, of course, we have the massive Bitfinex hack of $4.5 billion. And basically this just goes to show that even though fundamentally these algorithms and these all of crypto fundamentally and mathematically is very locked down and decentralized, there's still ways to go about hacking it, right? And this was kind of the reasoning behind kind of doing this research and moving into kind of hacking crypto web apps. So kind of crypto's open secret is this massive lack of decentralization, right? If you didn't read about this hack, the BadgerDAO hack, it's really interesting. Basically what happened is a company called BadgerDAO, they were going to open their website, and the hackers knew that they were going to open their website. So what they did is they pre-registered the Cloudflare accounts for normal emails that they might use. For instance, support@badgerdao.com. And what Cloudflare was doing was it wasn't verifying your email address when you made the account. So what the hacker did is they registered to Cloudflare, they generated an API key, and then they immediately took that API key and just held on to it in hopes that one day BadgerDAO would register to Cloudflare, which they did. So once BadgerDAO registered to Cloudflare, they had the API key. They basically used the API key to inject JavaScript into the web app that BadgerDAO used, and they were able to make these very calculated decisions on, we're going to inject JavaScript into this browser, and we're going to use the Web3 modal like MetaMask, and we're going to prompt the user to basically have access to all of their assets, or just intercept the money and take the money that they were going to deposit or withdraw. So this kind of leads to the fundamental part of my experience hacking crypto stuff is you're always going to have that web layer, right? So even though you have MetaMask, which is connected to Ethereum and like uses all the Ethereum nodes and stuff, like you need to be able to advertise that to users. And like, you know, you're going to use a Discord server, you're going to have a Telegram chat, you're going to have a website, and these are all like three, you know, points of failure that a hacker could go in and basically like compromise your site. And this kind of leads into, and I guess to introduce the format of this talk, we're going to go over like individual issues I found over the last couple of years. But the first issue I ever found on a cryptocurrency exchange is just blind XSS, of course, the trusted blind XSS. So what you could do on the website on Paxful, Paxful is basically like, you know, I've got an Amazon gift card and I want to buy like Bitcoin, so you trade with each other. And Paxful acts as like kind of an escrow, right? So what I was able to do is just, you know, what any hacker would is, and that's just throw blind XSS payloads everywhere, right? And one day I realized that the blind XSS payload had fired. Not only did it fire, but it had fired in two different contexts, right? So the left user, you can kind of see there is less options than the right one. So the left one, if you can see it pretty well, it doesn't have the Paxful core one, but the right one does. And the reason for this is because internally on the Paxful administration panel, they had two user groups, right? They had moderators and administrators, right? So what we were able to do is basically just like compromise the administrator panel, or excuse me, we were able to, you know, when building our POC, what we did is we made a POC that accessed the data in the core wallet. And what we realized is that even though the moderator users didn't have those buttons, they could still access the data. So it was kind of like an internal privilege escalation. And I apologize, there's the title of that. So the camera's in the upper right corner, so it's probably going to block something, but that's the title there. Awesome. But yeah, when I saw it fire and when I fetched the page, what I realized is that there is a wallet controller, right? And internally, this is a page for administrators to mess with stuff, right? And it's basically a form where you can test the wallet. And there was a input field that was disabled that had 0.001 Bitcoin to test if the Bitcoin network was up, right? So this was basically vulnerable to CSurf, and you could change the amount. So an attacker could have just, you know, taken the 300 Bitcoin via CSurf, or they could have gone and, you know, done the blind XSS and gotten the administrator cookies and accessed the core wallet. Additionally, like, you know, this is all the findings, but they paid a bounty of $20,000, and this was in 2017. So that was a fantastic like bounty for this. So super interesting. So you think, you know, 2017 to 2022, has anything changed? You know, we should have the saving grace of the internet and like all the security that should have came out, but realistically, straight into the exact same thing. Blind XSS number 2 on a website called Wyre is pretty much exactly the same thing, right? What Wyre is if you go to MetaMask and you want to buy like cryptocurrency, you basically just like you go through the MetaMask and it connects to Wyre, which is basically just like a payment platform for cryptocurrency. But I was able to register a business, and I found out that there's, you know, blind XSS into the user panel, where basically you're able to review the compliance, all the information about the user. And I think there's a really good Whitey Cracker quote from a song, and it's basically just talking about, you know, I guess some things never change, humiliating all these fools with the same games. And it's basically just the idea that, like, you know, 4 years ago and now we're doing the same thing. Like, security is like the methods we use are all kind of, they're reliable more than anything. Maybe less so than now, but still, you know, kicking at it, right? But Wyre ended up paying a bounty of $10,000, which, you know, a little less than Paxful, but there wasn't direct access to funds, so hey, still a very like kind of fun bug. But, you know, we'll switch to you know, talking about more. You know, in 2022, who owns your crypto, right? So it's like a really interesting thing. It's like if you go to the cryptocurrency exchange and you deposit money in, like how do you get the money out, right? And who is actually providing the liquidity for your cryptocurrency? So like an interesting thing you'd think is, you know, Binance has their own like API internally that has all the crypto, and they have like this really locked down like where they're doing these like raw Bitcoin transactions. Like you deposit into, you know, Binance, and then you would think that Binance would just like keep that in like their internal vault, and then they'd, you know, make changes to that. But realistically, what they do is Binance goes through a company called Prime Trust, and Prime Trust is basically an API that's built for a company called Fireblocks, right? So basically, what Binance does is if you want to, you know, deposit or withdraw money, Binance calls an API for Prime Trust, and Prime Trust calls an API for Fireblocks. But at the end of the day, the bottom of the chain is Fireblocks, where they do an insane amount of liquidity. And, you know, a company like Fireblocks provides liquidity for tons of different cryptocurrency exchanges. So, you know, you would maybe think like, oh, if I'm going to hack a cryptocurrency site, then I really need to have all this like crypto knowledge, right? But realistically, like trying to hack a crypto site is like, can I compromise the Fireblocks API key or the box that they're using to do the transactions? And if so, you're basically able to do, crypto stuff, right? And it's just like an API call, like they're leveraging like a, any other API that you'd leverage. So it's like a really fascinating thing to think about in terms of, do I need like this specialized skill set to hack cryptocurrency websites? The answer is plain no. You need, normal AppSec experience. So the third issue is actually a kind of more technical actual vulnerability. So there's a SQL injection vulnerability on this website called Vulcan Forged, right? And Vulcan Forged employs the wallet, the third-party wallet, right? I don't think their liquidity provider is Fireblocks. I think it's a different company. But we were looking at their website and we found a SQL injection. And with the SQL injection, we're actually able to, let me see if I have slides for it. We're able to, dump the tables, and we saw like a users table, like private keys and all this stuff. And, we immediately reported it and they immediately fixed it. But what was really, really, interesting is like, I think 3 or 4 months later, they were hacked, or 6 months later, they were hacked for the exact same sort of, I don't know the technical part of the vulnerability, but they were basically hacked where someone got access to the API keys for their liquidity provider and they're hacked for $140 million. Do I know if, this SQL injection could have done the same thing? I think there's a chance that it had the same impact. There's like a, API keys table and users table, but like, it's really, really scary to think about that like a vulnerability like this, where it's just like very traditional SQL injection with SQL map, leads to, potentially someone leaking or stealing $140 million. This was 6 months after our attack. We had nothing to do with it. We had DM'd the guy on Telegram and reported the issue, and I think they paid like a small bounty. It was like $2,000 or $3,000. But it's really, really scary to think about that. Like, there's still these like stacks that are set up in this way, where it's like, okay, we've connected our liquidity provider with API keys, and yeah, you SQL inject it or you hack it, and it's like boom, you've stolen all their records. So kind of at this point, though, there's the introduction of the Ethereum and DeFi like ecosystem, right? We have our savior, Mr. Vitalik, who has introduced like this very big like decentralized world, right? You've got like Uniswap, you've got MetaMask, you control your own keys. It's beautiful, right? But the issue of this is like the stack is getting more and more complicated, right? Like you've got, if you want to access your MetaMask, you click a button, and the button calls out to all these RPCs, which are websites, and the RPCs tell you how much money you have and like what you can do. And then when you interact with a website like Uniswap, the only way you really know that the address that you're talking to is the correct one is if, 1, they haven't leaked their API key, and 2, they like, they've signed cryptographically somewhere that like the website you're accessing is like the correct website. Because realistically, Uniswap is just a normal website. It uses Cloudflare. It's hosted on something like Next.js or Vercel or something. Or I guess they're technically the same. But yeah, sorry, a bit of a cut there. But anyway, the really interesting thing for this is like, you really don't know what you're buying unless you're actually checking, the actual addresses, and it's hosted on IPFS and the keys aren't compromised, right? So this isn't necessarily cryptocurrency, but this is basically an example here on the Banksy website where someone was able to hack the Banksy website, and what they did is they just sold a fake NFT on the website. And since there's no cryptographic verification or anything like that, people just assumed it was Banksy who was selling an NFT. So the bid on this actually got up to £244,000, and I think the scammer actually refunded the money, but it's a really, really fascinating case where it's like you have this integrity problem with crypto of like, how do we know who's who and what are we going to do about it, right? And this kind of brings the next point of like, where are these decentralized finance apps actually being deployed? And they're being deployed on places like Vercel using Next.js or like Netlify, and sometimes they're being deployed on like IPFS. But even at the very end of it, they're being deployed on top of TLDs, right? And this is like a very like core integrity problem on the internet. You've got like BGP hijacking and like DNS hijacking, and like, you have all these like big services that are running these, cryptography or these DeFi platforms where people just trust that they're sending their money, right? So if someone hacks Vercel or Netlify or Next.js or finds a vulnerability in like a TLD or whatever where they can take over the website, they can basically pretend to be the actual website, and that's a really big problem. So this is actually a vulnerability. Make the camera a little smaller for this. So this is a vulnerability I found in Vercel, and Vercel runs about, I would say, like 60%, 70% of crypto web apps, right? So what Vercel does is basically they provide some website where you authenticate, you link your GitHub, and you can just like one-click deploy apps, right? And while testing it, we found that there was this account takeover vulnerability where In the GitHub callback functionality, which is used for the OAuth login, there's no validation for the state parameter. So you can basically just like paste this string to someone, and if they open it authenticated, the GitHub gets bound to their account, and you're basically got like full account takeover in Vercel. And the impact of this is like pretty insane if it was actually targeted. Like if you took over like one of the big like $1 billion volume whatever things, you could basically just display whatever you want and steal tons of money. And I'm kind of surprised that like I can't. That sounds like a. I was gonna say I was surprised Vercel hasn't been hacked in like a malicious way yet, because it seems like such a ripe resource for attackers. I'm not saying to do that, but it's just like people are becoming more and more aware of these sort of attacks that can happen, right? So I think more and more malicious people are getting kind of opportunistic because it's like, okay, if I can compromise the website, can display whatever I want, and I can steal tons of money, so why not, right? Why not? So to get into kind of like a longer slide, and this is kind of one of the more technical slides, so we'll kind of go over it briefly, but you can kind of read about it a little bit. What are the crypto attack vectors for like web vulnerabilities? So if the app is self-custody, like users use their own private keys, where is it hosted, what libraries does it use, and is there anything imported on-chain that we can like display on the website, right? So to kind of go about this, the idea would be that we compromise like the integrity of the website, right? So our goal is just simply to become the website, post content on the website, or somehow take over a issue in the integrity part, right? Now this could be, instead of taking over a website, maybe we like take over a Discord chat bot, right? Or we take over a Discord account. And if we take over the Discord account, we can just do @everyone, please buy my NFT at this website. And people do it because, crypto culture is like very like ape-en, like buy the stuff as soon as you can, otherwise you're going to lose out, right? So if the app does have custody, like users who trust the website to host their keys, one thing we can kind of ask is like, does the app use Fireblocks? Like, do they have a monetary provider? And do they set that up in like a good way, right? So if you build like a cryptocurrency web app that leverages something like Fireblocks, there's correct ways and incorrect ways to build it, right? So one correct way is that even though you've got like your website, like you've built like your cryptocurrency exchange, and people like come in and create like a user account, each user should still have their own individual wallet, right? But if you decide to make it in a way where it's just like, okay, we're going to have one wallet. So if you deposit it, we're going to transfer it to a big account, and the big account is one everybody shares, right? That introduces potential logic vulnerabilities like negative amounts of money, trying to send or receive, race conditions where you're able to increase your balance. And if this happens, then you can basically like kind of exploit like the gated garden of you're able to kind of send money around and generate money out of thin air and steal other people's money at the end of the day. And the last part, we kind of talked about it before. A lot of cryptocurrency exchanges aren't using crypto anymore. If you want to start hacking crypto web apps, come join us. Like it's very much traditional web security. But yeah, like Fireblocks has handled more than $500 billion in assets, right? It is very large. If someone was able to find a core vulnerability in Fireblocks, it'd be very absurd. They at the end of the day, they do use like tons of crypto stuff. They have like multi-chain, whatever. But they're also at the end of the day like an API basically. So finding web vulnerabilities in Fireblocks, really interesting. So let's bring us into like issue number 5, right? So with this issue, it's basically a universal XSS on a Nuxt image library via improper host parsing. The way this basically worked is pretty simple. Like, if you guys have seen like kind of traditional web vulnerabilities, like you're able to trick the website into thinking you're loading a resource off a whitelisted host via doing, attacker website and then %5c or a / at whitelisted host. And the URL parser kind of breaks. It thinks it's talking to whitelisted host, but realistically it's talking to the attacker website. And what you're able to do is just load in like an evil SVG file. Gave us a bounty of a swag box. The hoodie is very comfortable, so I'm very happy with that. So whatever. It's one of those things where reporting it to the provider, you're not really going to get a bounty, but like you could maybe find a customer who was affected and kind of report it there. Obviously do both, but whatever you, however you want to play the game, it's on your discretion. But this is kind of an interesting issue because this is a universal XSS on Nuxt image, and Nuxt image is used like everywhere for crypto. So like you're basically able to have XSS on like any crypto or a ton of crypto websites, and it's like why not just exploit the integrity there and make a ton of money or whatever. So that's just kind of a interesting issue there. So kind of another similar issue is like a universal open redirect on Next.js. And Next.js is the same thing. It's deployed through Vercel and it's used on like every crypto website. And what you're able to do is, in the next image library, you're able to do, // and load in a resource from attacker-controlled domain or redirect the user to an attacker-controlled domain. We actually reported this to Vercel, and then we also reported this to affected customer where it was account takeover, and they were generous enough to give us like a $4,000 bounty, so that was really nice. Kind of a similar thing is there's another universal XSS on HubSpot CMS. So HubSpot CMS is kind of I think it's a managed solution similar to like WordPress, right? Where they're able to host like your blog for you or whatever, and tons of crypto sites use this for their blog. Let me scroll this down. My camera's always in the way. So, Circle.com, they're basically a provider for like, I think USDC or some other stablecoin. But you're able to get XSS on Circle.com via basically, you can see the HSFS endpoint. This endpoint here is reverse proxied to their CDN. So basically what you're able to do is post content to the managed like HubSpot resources where you're able to post an HTML file with custom content, and you're actually able to access that HTML file on any customer website. Because what you could do is find the resource like URI for the actual asset and like load it in on any customer. So when you did this, universal XSS, and there's another interesting thing with HubSpot is they have another endpoint _HTMS diagnostics, and what this endpoint does is reflect your whole cookies, right? So even if you've got HTTP only cookies, if they're being sent to the web server, they're going to get reflected via this. So you basically had a way in which you had one XSS, and two, you could steal everybody's cookies, their HTTP only cookies. Kind of issue number 8, it's like a very similar issue, right? For Instapage, you could basically, or I guess not similar, sorry, it's a subdomain takeover basically. So when you add your website to Instapage, you could just append like null bytes to the domain that you're adding, /u0000. And what that did was basically give you write permission for the website. So if you found a website that was live and being hosted on Instapage, you did that, you're able to post content to any website. So for our POC, we took over about.instapage.com or published content to it. And again, Instapage, like another really big, crypto host, right? So you could have done a lot of different stuff with that. Here's another kind of interesting thing, similar sort of issue, right? This is like improper host whitelisting on Gitbook, and basically what you're able to do is similar endpoint, right? Curly thing /files / this endpoint was able to basically reverse proxy assets from appspot.com, and they basically had to check that it began with gitbook - whatever, and then it ended at .appspot.com. So what we could do is just register gitbook - x - heck.appspot.com and post a file, and you're able to create like an HTML file that you can basically access, right? And Gitbook is used like everywhere in crypto as well. They're all the API documentation people have. So for all of these, the attack scenario is basically, there's no integrity on what's actually being, like the website itself is the only the only thing people can trust, right? So if you send someone a URL that's like, CryptoKitties.OpenSea.io, people are like, okay, it's probably CryptoKitties. So then you have, your fake page, which is like, hey, send me $1 million, and people maybe send you $1 million. So here's the another one. There's a ton of similar issues right in a row, but universal XSS on landing eye via cross-tenant load, right? So basically for this one, when you're creating a page or a landing page on landing eye, you can basically preview your page on your own website, and what you do is it gives you this parameter called export hash, right? So if I make my website and I want to preview the website before it goes live, it's like, okay, use this parameter and preview your website using it, and then you can see what it looks like, right? But the issue with this is that it basically let you do it for any tenant. So, advertising.crypto.com, we're able to just append, export hash or whatever, and there wasn't actually a $1 million giveaway. Should probably change this slide so it doesn't actually look like it's real or whatever. But you could load in your own attacker-controlled HTML file, and then pretend to be crypto.com, which is lots of advertising around that domain name. Be kind of a fun bug. So to kind of take a step back from all those like individual issues, in 2011 with the introduction of like Bitcoin, you have the Electrum wallet, right? The Electrum wallet is like you download the chain, and after you download the whole chain yourself, you get to see all your transactions, all the money you have, and all your wallets, and you manage it yourself, right? It's very straightforward. You're sending, receiving money, goes through the different nodes. It's like actually decentralized, and at the end of the day, it's very like isolated. It's a binary, like, you know, it's like one thing, right? But now, if you want to access, you know, the decentralized internet, you go through Cloudflare, which goes through DNS, and it's on Vercel, and it's got npm modules, Next.js, and in order to verify your transactions, you use Etherscan, and in order to look at your NFTs, you use OpenSea, and all of this go through like Infura RPC nodes. And at the end of the day, there's so many points of failure, potential points of failure, and it creates like this very vast like attack surface for new crypto, you know? Even though at the end of the day, it's like, you know, a user may have to like manually approve the transaction, there's still like a ridiculous number of ways you can go about like compromising the stack. So my opinion is that 2011 was probably a little bit easier to secure, and 2022 is like harder, right? So issue number 11, kind of have a bigger bounty for this one. There was a remote code execution vulnerability on a stablecoin website with a market cap like $150 million, and they hosted another service, right? They hosted it on their AWS stack. They had another sort of website that you could use where you could upload files, right? So what you're able to do is just traverse the file upload and upload to like ets cron tab, because it was running as root, right? And once you did that, you're able to run commands, right? And just basically get a shell in the box. And once you had a shell in the box, you could basically see that the AWS secrets let you, you know, do AWS stuff, right? So once you connected to AWS, you realize that basically you could pivot between the compromise of the, you know, side website, right? You can basically pivot into the core stablecoin website. And, you know, at the end of the day, for stablecoins where you convert United States dollars to stablecoins, there has to be some sort of provisioning system, right? And I think, if I don't understand the impact incorrectly, you're able to actually access the system and, like, you know, provision yourself stuff or access the dashboard to do this. So super scary bug, but yeah. They ended up paying like a $50,000 bounty. Super grateful for that, but yeah. Crypto bounties are interesting. It's definitely like a different landscape. Some people would say this bounty is like low, which if you look at the impact, it's like, yeah. But realistically, we're getting into a better part, right? With $50,000 bounties, with $100,000 bounties, like there's good bounties now. So lots of reasons for you to hack stuff, right? So the second kind of big vulnerability is like we were able to compromise the entire TO TLD. And the reason we did this, because we were originally looking at Tether, right? We're like, there's so much news about Tether. We're really curious, you know, securing Tether or whatever. And we realized it was running on a .to TLD, and we're like, okay, that's kind of interesting. We've never seen this .to TLD, or at least we haven't really thought about it. So we got to see how they do their, you know, provisioning for stuff, and we realized that they're running on a very like it's kind of an older website. They've existed, you know, the two guys who run the TO TLD, they're both named Eric. They're really smart people, and they've been running the website since, you know, it was I think the first actual registrar was TO Domains, right? It stands for the island of Tonga, and you're actually able to go on the website, even like, you know, 2000 or however early it was, and register a domain name. But it was vulnerable to SQL injection, and what you're able to do is dump the password for managing the DNS information for the host, right? So an attacker would have been able to basically pop this using SQL injection and access the DNS management for tether.to. And tether.to is kind of the same thing, where it's like a provisioning system for buying and selling Tether, right? So if you pop this, you're able to take over any TO domain. But I think overall, more broadly, it like speaks to the idea of like, you know, we are so far away from having a decentralized crypto, right? Like, this is like the aspect of this and like the implications of this is like, hey, you know, even if you get as locked down as possible, like there's still ways to go about like compromising the stack, which is not decentralized, or is like, you know, because technically DNS is, but you know, it's iffy. But anyway, TLD vulnerabilities are like the peak, I feel like, of like we found a hole in the whole system, right? Where it's like we've compromised the whole thing. But yeah, super interesting bug, but allowed us to take over tether.to and any TO website. So sorry, I'm kind of speedrunning these. But anyway, issue number 13 is like a full account takeover vulnerability on Crypterium, right? So Crypterium is like an exchange, and this is kind of a different type of bug because it's more like a custodial platform, right? But what you're able to do is just, you know, orange side type trick of semicolon / and access the internal API for it, right? And we found this API doc that like exposed the internal API routes, and we're like, okay, how do we access this one? And what you're able to do is provide like a phone number, and you're basically authoring any account, right? And it generates a session cookie, and you're able to take it over. Next bug, like issue number 14, is like full account takeover on roll. For this one, they basically weren't verifying who the user was, and you're able to basically throw in like a 6-digit code and like connect your 2FA to another user's account. And once you connected your 2FA to another user's account, it actually reflected an authorization bearer, right? And that authorization bearer was actually the authorization bearer for the user where you're adding 2FA. And once you had this, you're basically able to like log in their account and do whatever you wanted. And it's full account takeover on another, custodial platform called Roll, right? So kind of like, sorry for the length of this with the 14 issues, but or the format, I guess, kind of harder to go deeper in each one, but kind of just like the final thoughts, right? Cryptocurrency attacks are like actually like super increasing complexity. They're getting very targeted, and there's so many things to like really be aware of when like things move forward this quickly, right? So you can kind of see, these two little photos, right? So here we have, OpenSea with like selling an item, and here we have like Geth, right? Like, I think the reason I include these two is I thought it was kind of funny. It's just like, you can either run your own like Geth node and like verify each and every transaction, in order to be cryptographic as possible, or you can just go to OpenSea, trust the website, do all this stuff, but it's kind of pick your poison, because one of those is like it's isolated. It's like, you're able to interact with just the thing directly, and so that you get to see the whole chain. But the other one leverages, all the websites and all this stuff, yada yada yada. But yeah. Anyway, so like reliance on browser extensions in traditional web is very complicated, right? So having to use MetaMask and having to go to these websites where you like interact with MetaMask gets like very complicated. There are some of these that make like some chain browser extensions like MetaMask or alternatives to MetaMask like auto-approve transactions for certain domains, right? So like let's say you use gambling.com all the time. You basically say like tick like, oh, I trust gambling.com, auto-approve every transaction on gambling.com. And that's like, okay, so if an attacker gets XSS, they can just steal all your money. That's cool, I guess, whatever. Attackers have like a massive incentive to innovate, right? There's like tons of money, it's free money. The community of crypto people is like the perfect like victim, right? There's a culture of just like throw money at whatever, right? And people aren't technical. People are just after some money. Like the number of users in crypto is getting so vast, and you can't possibly share enough resources that, people could, like say I did like phishing trainings, right? Like for how much money we invest in phishing trainings, like people still get phished. But yeah. And then kind of the last two, like no one's downloading a copy of the chain. Like nobody does that realistically. If you're like a dude who's buying stuff, like you're just gonna use your MetaMask and like check stuff yourself, or you're not gonna check stuff yourself, right? You're just gonna depend on like the third-party stuff, like Etherscan and all this stuff. So, compromising these big APIs, you could basically pretend to be crypto, even though it's not cryptographically verified, right? Like if you pop Etherscan, you can basically, if you pop like Etherscan and Fura and all this stuff together, you could basically be the new Ethereum for 90% of the user base, right? The APIs provide truth. Like that's all there is to it. Is like people don't verify stuff, and APIs are leveraged to verify truth, right? So now crypto isn't crypto. Crypto is web. It's kind of falling back into itself a little bit. But I think that is pretty much all. I think I messed up this a little bit. Brett wanted his name to be bigger, so I made his name bigger for this. But yeah, thank you for watching this. I think the time may be a little weird. Maybe went over, maybe under, but I'm happy to answer any questions. If you want to reach out on Twitter. But yeah, I hope everybody kind of walked away with an understanding of just like crypto vulnerabilities are a lot of times more web than crypto, and the ecosystem needs a lot more people to help kind of like secure it. And there's a big incentive for people to come help secure crypto, right? Again, thank you for watching. Thank you so much. And sorry if this, again, like if this talk seemed rushed or anything like that. I'm really doing internet talks or doing pre-recorded talks is like, it's pretty rough, It's always hard to tell like what time it is or like read the room or whatever. But again, yeah, thank you so much. Thanks, guys.